Hey, hello. Welcome to the second lesson in this series of online workshops that will help us better understand what FLR is, what you can do on FLR, and how you can leverage all these awesome technologies to build something really amazing on a blockchain. Like before, I'm Philip, head of DevRel here at FLR, and we're going to see a bit more detailed technical discussion on what to do. And today, finally, we're going to get our hands dirty and we're going to deploy a smart contract, interact with it, see what it can happen, and also be able to create our own new token. Okay, so in the first workshop, we've explained what FLR is, what the specifics are. In the second one, we'll go deeper. We'll finally create something. Even though it might sound difficult, this should be available pretty much to everyone that has even no programming background, because we're going to start from the beginning. We're going to create some code, and everything I'm going to be showing today is going to be recorded, and all the code will be available at link that's going to be also available at the end of this. So you can try this again. You can try this however many times you want, and it's going to be on testnet, so you can play with this, play around, and do whatever you want. And at the end, you'll deploy something new. And as before, I was told not to reveal too many alpha, but if you wait until the end, there might be a Q&A, and there again might be a surprise. As previously, there is going to be a Q&A at the end. So John will be collecting any questions you have, anything you might want to ask about FLR, anything you might want to ask about the tutorial we have, what to do in the future. We'll try to accommodate you, and we'll try to answer as many questions as possible. And maybe just to answer the question from the last time that we had on Discord. So yeah, we're going to create a similar session when we're going to showcase what other people from the community are doing. You can also check, if you want to see what people from the community are doing, our regular Twitter spaces. But previous month was quite busy because we were doing a lot of hackathons and a lot of things have been happening. So we're still organizing this. Okay, so just so that I had something to prepare with the slide. This is the same slide as we had last time, but this time this slide is going to serve a bit different direction. So this is a blockchain. We've seen what blockchain was previously. We've seen at least what it should be doing, but today we're going to focus on a totally different thing. So blockchain is a chain of blocks, contains transactions, and importantly today for us, it contains state changes. And this state is going to be the crucial part, because you see the smart contracts, the programs that run on blockchain, do not only allow you to send transactions between different addresses and to pay somebody for something that they do, but they also allow you to change something else on the chain, to change some state that is not necessarily financial state on chain, and also set how you want to interpret this. And this is going to be the core thing of the token that we're going to be deploying today. We're going to say how to interpret something, and we're going to say how to change it. How this is done underneath differently, if you're familiar with Ethereum or any other blockchain that follows the same principle, this thing, changing the state and executing the transactions, executing what's happening in between, is done on so-called execution layer, part of the blockchain, where validator nodes execute each transaction independently and verify that other verifiers have properly executed these transactions independently. And those transactions then change state, can observe the state in the middle, and can act upon it. That's the important thing. So there are very few limitations what these intermediate state transitions can do. And because in the middle we have a full-fledged programming language, you can perform pretty much anything you want, constrained with some gas fees, constrained with what the blockchain can do, and also constrained with what your specific blockchain allows you to. In the next few lectures, we'll discover what are some pitfalls of programming on blockchain, what are some restrictions that you need to take care of when considering blockchain, and how different blockchains, specifically FLR, solve those specific pitfalls, and how do they allow you to do something that's not doable somewhere else, or that's very expensive, very unsecure, or practically impossible to do it. Okay, so smart contracts. Although they might sound difficult, smart contracts are just programs that live on blockchain, and they get executed by the validators. So instead of your computer program that gets executed on a computer or in the browser or on your mobile phone, smart contracts are programs that get executed during the transaction execution by the validators. And you can think of them as pretty much a programmable extension of the blockchain. So Bitcoin initially just had transactions. Okay, they've added some additional scripting abilities, and you can do quite a lot of things, but they don't have the full-fledged programmable extension. The important thing is, as with all the blockchain-related things, that the limitations placed on them are very, very low. So the first thing is, on EVM blockchains, and specifically on FLR, they can be deployed by anyone. The smart contracts are not limited to a specific set of developers or a foundation or to somebody that's controlling this. Anyone participating in the network can deploy a contract, can program it however they want, and can interact with smart contracts deployed by other people. Why is that important? Well, it's important because of the ability of the ecosystem to grow with respect to what others are doing. So that's important because it allows the blockchain to scale. It allows the blockchain to do something else besides just the initial thing that's initially on it. And importantly, as with other computer systems, we have to at least mention what kind of thing we are running on the blockchain. So FLare specifically uses EVM, so it uses Ethereum bytecode to process this computational part in the middle. Why? Well, this is the most common language. This is the most common execution language that is used. So that means that all this tooling support, all the necessary bug fixes, all security features, all this can be integrated from somewhere else. And it's easy to incorporate people from other ecosystem, and it's also easy for people to start working on it. But there is a small problem, which is that EVM bytecode looks like this. This is an excerpt from a very simple token contract. This is just the first 10 opcodes out of it. And humans are not naturally predisposed to read and write code like this. So we usually opt not to write EVM directly, not to write the Ethereum opcodes directly, but we usually write in a higher level programming language that then gets compiled to opcodes. And the most commonly used programming language to do this is currently Solidity, but there are also other alternatives if you want to try them. The important thing is, as long as your language compiles to EVM, you can use pretty much anything you want. But from what we've observed, a huge majority of things deployed on FLare are written in Solidity and then compiled to EVM because that's just the easiest thing to do, the easiest to debug, the easiest to develop. And let's jump in. Okay, so today is going to be a bit different. We're going to be doing a lot of work. We're going to be providing some code. And the first thing we're going to do is we're going to create a simple counter contract. So here's a screenshot of it, but don't worry. We're not going to be copying the code. We're going to be writing it from scratch and explaining what it does. So here's a contract in like 14 lines of code that the only thing it does, it has a specific variable named count, and then increments and decrements this count according to the transactions that are added to it. And let's have a look. So what we're going to do is the following. We're going to connect our MetaMask to Remix, which is an online IDE you can use to interact with EVM blockchains. We're going to get some tokens because you need tokens to start deploying anything on networks. We're going to get some tokens from the faucet because we're going to use a test network. And then we're going to write the contract, publish the contract on network, try to interact with it, see what's happening, see the things that can go wrong. And then at the end, we're going to verify this contract, which is a very important thing, but we'll explain why exactly we want to verify it a bit later. Okay, so I'm just going to switch to my other screen, and let's start working pretty much immediately. So the first thing we're going to do, and this is the first thing you have to do if you want to do this yourself, is set up the MetaMask. This can be quite a tedious process, and during the setup of MetaMask, 12 or 18 or 24 boards would pop up on my computer, and you would be able to see them and catch something out of them. So I'm not going to be setting MetaMask up right now. If you want to know how to set up a MetaMask, there are a bunch of tutorials. One of them will be listed in the final document that you'll get to be able to see at the end. So you can follow that one. So we're going to assume you start with the MetaMask created. And I'm just going to show you how to add custom network and how to start to get some faucet tokens. Okay, so the first thing you need to do is you need to add custom testnet network. This is Songbird testnet custom. You can also add FLR's testnet, which is custom too. Both of them behave in a very similar way, and there are only minor differences between them, which are irrelevant for today's purposes. So the easiest thing to do is you just go to custom RPC FLR docs, and in the developer hub, you can search for custom. Maybe the easiest thing is just to go chain list custom. And in chain list custom, you can have a bunch of RPCs and you can just add it to the MetaMask by a simple click. Okay, so once you do this, MetaMask will pop up. It will ask you if you want to add the network, and then you can just select Songbird testnet network custom. Okay, so this is your MetaMask, this is your account, and the next thing you need to do is you need to get some custom FLR tokens. So I have a bunch of them already, but it's always useful to have some more. So, and the easiest thing to do is to get them through something called faucets. What are faucets? Where faucets are small web pages that distribute small pieces of tokens that you can use on blockchain, and their main purpose is to use them during the development phase on test networks. So test networks do not have any value. The tokens on them do not have any value and are meant only for development, but you still need something to pay for gas fees. And faucets allow you to get these small amounts of tokens. And again, just search cost on faucet. See, you can already see it in my history. Up there, insert your address, and you'll get some custom tokens. If you want to get some custom 2 tokens, you can request them the same. And we're pretty generous. We give you up to 100 tokens per day per address. So as long as you're not doing something really, really strange, that should be sufficient. So today's exercises will consume maybe 15 tokens, and out of this, a huge majority, 14.5, will go towards paying for things and not towards gas fees. Okay, so we have some tokens, and if I take a look at my MetaMask, I'm able to see that I got something more. Okay, so now I'm set. I have my MetaMask ready, I have custom network ready, I have tokens. Let's get to coding. So let's create this simple counter contract that will allow us to make some impression on the blockchain and do something. So this is Remix. It is a web IDE, so it allows you to develop, but importantly on the left, it has some additional plugins, additional things that allow you to a bit more nicely interact with Web3 interfaces. It allows you to directly connect MetaMask. It allows you to, for example, add a plugin that allows you to verify contract directly out of it, and it immediately compiles things. It's nice for learning. It's nice for getting things ready for playing around. But if you want to do a bit bigger project, if you want to deploy something bigger, if you want to develop for a longer time, I would suggest you develop things locally, although Remix ID is quite powerful, so you can also connect it to Git and do a lot of things inside it. But for the bigger project, it's usually better to have a local deployment, a local development with ID of your choice. I usually use Visual Studio Code, although people use pretty much any ID you can think of. Okay, so the first thing we need to do, we'll create a new file. Let's call it counter.sol. This .sol is a standard suffix for Solidity files. Why do we use a standard suffix? Because we want the Solidity file to be recognizable by both the syntax highlighter and everything else. Okay, so let's start with a very simple Solidity file. And the first thing you need to write is a pragma Solidity. And then you say, okay, which versions you're going to allow. So here we say, okay, pragma Solidity, version greater than 0.8.26. You can be here you can be very dynamic on what you allow, although there are some security holes in previous versions of Solidity, and versions below 8.0 behave a bit differently. So everything we're going to be doing today works fine with versions above 0.80. But if you're going to go below 0.80, there are going to be some minor differences. Nothing very specific, but something to be careful about. Okay, and let's create our first smart contract. So contracts are similar to classes if you've ever programmed within an object-oriented language. So if you've done some Java, or JavaScript, or Python, contracts behave very similar to classes. It's a pretty much a new type you define, and you can create instances of these contracts, and a specific contract, a specific class, has some fields and methods it can interact with. The difference is how those methods are getting called and who is able to interact with them. Okay, so let's create a new contract. My counter. So create a contract, we give it a name, and we put curly braces around it. So you're going to see a bunch of curly braces, which is pretty much the historical, for historical reasons, because how the language looks like. Okay, and we're going to create a simple contract, my counter, that is going to do three different things. First thing is going to be, it's going to hold a counter variable, which is going to be an integer just holding a number. And then we're going to have two methods. We're going to have a method increment that is going to increase the counter by 1. And we're going to have a method decrement that is going to decrease the counter by 1. And that's it. Only those two. But that's the beginning. And we're going to have some state to change. So let's first create this field, uint256. So this is the base data type in Solidity, which is unsigned integer 256. In older versions, you could also write without the 256, but it's usually just better to write it with 256. So that is an unsigned integer that is between 0 and 2 to the power of 256 minus 1. So it can hold a lot of things, much more than your normal fixed precision integer in your usual programming languages. We're going to make it public. Now we're going to see why this is important at a later point. And we're going to give it a name. Let's call it count. Oh, it doesn't matter. So it's a name of the variable. You can rename it. But due to how Solidity works, the name is important on how people for how people interact. Okay, so that's a counter. And an important thing about Solidity is that everything is always implicitly initialized to 0. So in a C++ or Java, if you were to declare a variable and don't assign it, don't say it's going to be 10, it might be undefined behavior, it might fall, it might fail or something like that. In Solidity, the thing I've written is the same as if I would have written equals 0. But let's be a bit more specific and say, okay, let's start with 1, 2, 3. Okay, so immediately after I press Command S or Control S, Remix compiles my contract and creates a bunch of these files called artifacts. We won't be looking at them, but it's important to keep in mind that every time I do something, things change, and Remix will remind me if something's wrong. And I get some warning here that I'm missing a license comment, but everything is fine. If I were to miss a semicolon at the end, the Remix would complain and say, okay, I was expecting semicolon, but got closed curly braces. So let's put a semicolon here. And we have a contract counter with a single field count. Okay, let's add two functions that are going to increment and decrement it. The main difference between ordinary non-Web3 programming languages is the fact that if you were to create a thing like this in Java or a similar structure in Python, anyone would be able to access this counter and modify it. Solidity compiles it in such a way that everybody is able to see this thing, everybody is able to see the value of the counter, but modification is always allowed only from within the contract. You can always create get and set methods, but you cannot call a specific contract and modify their fields directly without an accessor and setter method. Okay, so let's create a function increment, and we're going to make it public so that anyone can call it. And the only thing it's going to do is going to say, okay, count plus equals 1. So count is previous counter plus 1. Let's be a bit more plus 1. Okay. So a bit more verbose. Again, Control S compiles this, and we have it. And let's also create a decrement function. Again, public, so that anyone can call it and say count is count minus, let's say, 12. That should be fine. Okay, cool. So we have this, and what can we do now? Well, the only thing we need to do now is to deploy this contract somewhere and see what's happening. Okay, so how do you deploy it? Well, first you need to compile it. We get this one small warning, which we're gonna ignore for now. Remix is also directly integrated with Remix AI that helps you understand these errors. We're not gonna go through them now, but we're gonna be able to. If you do this yourself, you're gonna be able to see quite a lot of how this works. Okay, so we just recompile it again. And then we have to create one small modification to the default settings, which is you go to the advanced configuration and you set the EVM version to London. That's because this is a specific version of EVM that's currently running on FLR. It's just so that specific optimizations are applied. This is a common thing to do, and not all the quite a lot of major blockchains don't even support the latest forks yet. So we just set the London one, and it's all right. So we recompile the contract. We're going to remember what exactly we've used here. And now it's time to deploy this on-chain. So deployment on-chain means that we create a transaction on-chain that is going to take this contract, take the bytecode of this contract, push it on-chain, and then this contract will be available for anyone on-chain to work with. And there's a few things we need to set. The first thing we need to do is we need to set the environment where we're deploying from. So here in the environment, you can say on which virtual machine you're working. So you can use the Remix's virtual machine that's ingrained, and you can use the local blockchain, so to speak, but we're not going to be using local blockchain. We're going to be using an injected provider from MetaMask. So I just select injected provider. It says custom 16 network. So this 16, this is the chain ID of custom network that I'm using. And it immediately shows me my account. So FF0 something, 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 and shows how much Ether, so how much funds I have available on it. Okay, so now I'm saying, okay, we're not going to be deploying on an internal blockchain. We're going to be deploying on a proper blockchain, in our case, the one that is selected by MetaMask. And the thing I also need to set is I need to say which contract to deploy. And I'm going to be deploying contract name myCounter in file counter.sol. Okay, so I click deploy, something's working, and immediately my MetaMask pops up because I need to sign this transaction. This is the important part. So to do anything on blockchain, you have to bribe the validators to include your transaction inside the block. So it's not really bribing. It's akin to paying for the block space, paying for the validation of your transaction. And even to add a contract, you need to pay this. And MetaMask automatically calculates this fee for me and shows me how much I have to pay, signs the full transaction, and the only thing I need to do is I need to click confirm. So I can go here into Hex, and this is exactly the EVM opcode I'll be deploying. It says how much of visit it's there, and it says some additional information. So I'm doing this from account 1, and I'm deploying the new contract. So I click confirm. I wait a second or so for the block to go through, and here it is. My counter has been successfully deployed. And Remix immediately tells me here on the left, look, I've deployed, you've successfully deployed the contract on the network, and here it is, and here are the methods you can use to interact with it. So, and recall before, so we've created a decrement, an increment, and we've created the public field count. And Solidity works in such a way that any fields you declare public immediately get an auto-generated getter that shows their value to anyone that wishes to see it, without you having to define the function. And then you can easily click here and interact with contact. So if I click count. A call transaction is emitted. I don't have to pay anything because this is just viewing the blockchain and not changing it. And you can see that the result 1, 2, 3. So it's the same thing I've saved into it. And I can interact with one of those two methods, but this method is going to be the important thing here. So this method is not just reading something from blockchain, it's creating a transaction that calls a contract, and during this transaction call, during this transaction execution, a contract changes something on the blockchain. So I need to sign this, I need to pay for this state change, and now every validator that sees my transaction will be able to execute it, confirm what the transaction has done, and broadcast to other validators that this specific thing has happened, and they can accept this newly changed state to continue in the next block. And then in the next block, I can start from a new state, and so on. Why is that important? Well, that's important because you can, with this execution part, you can use blockchain to store data through time and to interact with other contracts, with other data points you need. Okay, so let's call increment. And this is going to create a transaction that I have to sign. So I'm signing a transaction, and you can see the transaction fees are really, really small. So I confirm this. I wait just for a while for this to get mined, and that's it. So a transaction has been executed. This function has been called, and let's check the count now, and it has increased. So when I call the count, the validator checks the block, sees what's exactly in that memory cell in the block where the count is residing, and because in a previous transaction somebody has updated this, I now get a new number. Okay, so that's it. The contract is deployed on blockchain, and it's functioning there. I can increment it, I can decrement it. Let's just call decrement once to see what happens. Confirm, wait for a while, and yep, 12 less. Okay, so that's it. I have a contract I can interact with. But what now? Let's just see what this contract looks like. So what I'm going to do, I'm going to check this contract directly in the block explorer. So this is deployed at 0x179. I'm going to copy the address, and I'm going to go to cost on block explorer. I'll go to cost on block explorer, paste the contract in, and see what's happening. So you can see here's the contract. I've made 3 transactions to it. The first one created it, and then I've called increment and decrement. Okay? But the thing is, if I go to contract here, I only see numbers like this. So I only see the contract creation code and deployed bytecode, but they're not very, let's call it human friendly. And most importantly, everybody knows what exactly is in here, but it's very difficult to reverse engineer this. For a simple contract like this, you can do it, but for a complicated contract, for example, holding a specific asset, holding an upgradable contract, or an FTSO or token, it's much more difficult. So it's very difficult for people to trust you that this contract is really doing what you're telling them to do. And it's also practically impossible for people to interact with them if they don't know which functions are available. So what you need to do, it's not necessary, but it's very important both for the purposes of the ecosystem and for other people to interact with it. We then have a mechanism calling verification. When you say to Block Explorer the following. So you say, okay, I see this contract here. I'm going to tell you I've used this specific code to deploy the contract. I'm going to copy my whole Solidity code to the verification process. And then Explorer independently compiles the code and tries to match the compiled version of the code with the code that is currently on blockchain. And if the two codes match, that means that the something I've used to deploy the initial contract has to be doing the same thing as the code I've supplied to the Explorer. And in that case, I'm pretty much verifying and asserting to other people that, look, this here really is the code I've used to deploy and compile the contract. And if you want to interact with it, these are the methods that are available on it. And secondly, anyone can always check how exactly this contract looks like. Okay, So I'm going to go here to verify and publish, and you only need to do a few things. You need to select the license. Let's select an MIT license. You need to select the verification method. I'm going to select a single file because I just have one file. I'm going to copy my whole contract here. And I need to select which kind of compiler, which version, and what kind of optimizations I've used to verify this. So what do? I go back to Remix and check my compiler settings. So I've used 0.8.26. I select 0.8.26. And remember, I've selected an EVM version London. That's important to set. And the final one, I need to check what optimizations I've used. So I haven't enabled optimizations, so I have to also disable them here. I click verify and publish, and boom, you see, my contract here is published, all the information, and I have exactly the same contract as here. And importantly, in the read and write contract tab, I can now access the same methods as within the remix. Why is that useful? Well, that's useful because now anyone can access this. Anyone can access this contract, and anyone can interact with it directly from the Explorer or from somewhere else. And something more, if you go to code, an ABI, an application binary interface file, is generated, which you can then include in your off-chain applications that will now know how to interact with this contract at the end. Okay, so we've deployed our first contract. That's a very simple contract, but it doesn't do anything specific. So one thing to note, you can also interact with those methods directly from Explorer. Just click on it, confirm. I do an increment. Transaction is true. And I read it again, and this immediately refreshes. So if you recall, it was 112, and now it's 113. Okay, so we've deployed a simple contract, a simple counter contract, but that's not the only thing blockchain can do. We're going to now see what else you can do if you allow your memory on the chain to be a bit more expressive. And we're going to deploy our own ERC20 token. So what is an ERC20 token? ERC20 token is a very simple implementation of a token that pretty much allows us to assign balances to specific addresses. So the most basic thing on a blockchain is an address, which is an owner of some wallet or some contract. And ERC20 token is a really old but very commonly used Ethereum specification coming from the Ethereum Improvement Proposal 20. This is where the name comes from. And the standard defines in the EIP says the following. The ERC20 token should have the following functions. It should have the function total supply, which returns the amount of tokens in existence. It should have the function balance of, which returns the amounts of tokens owned by the account specified in the argument, and it should be able to transfer to address designated by 2 a specific amount of tokens being held by the current owner. So those two functions effectively say a token should be transferable and should be able to say who holds how much of it. And the total supply is just a nice function to have to know how much token there is around. Then there are also 3 more special methods which are very important for blockchains as such and for interactions with other dApps, which allow you to set somebody as a spender for your account. So instead of just me being able to send token to somebody else, I can designate some spender with some specific amount to spend to ease the development process. So every time you interact with Uniswap, you are firstly prompted to allow the Uniswap router or the Uniswap pool to spend some of your tokens. And then each time you interact with it, the Uniswap uses this allowance to spend it instead of you having to do a bunch of work to send tokens whenever Uniswap wants it to. So those 3 functions are there to allow much, much easier user experience, and they're constantly being upgraded and new versions are coming out but think of them like a really, really simple precursor to account abstraction. And what do? Well, the first one is allowance. It just tells you how much a spender is allowed to spend from the owner. The second one is approve. It says, okay, me, the owner, I want to approve some spender to spend some amount that can be taken from my balance. And the third one is pretty much executing this and can be executed by spender and say, okay, I'm going to spend some tokens from the from address, send them to address with this amount. And if the spender is allowed to do this, this is a transaction done instead of somebody else. So pretty much you're delegating the ownership of your tokens to somebody else, but not immediately, but they can spend them on demand. Okay, so these are the functions that the token needs to implement. And there are two different events that are emitted. First one is transfer, and the second one is approval, which get emitted whenever somebody transfers some tokens and when somebody approves to spend some tokens in their stead. So the events are very useful for off-chain monitoring of the chain, and we'll see them how Explorer uses them to detect what's happening within our contract. Okay, so we're not going to implement all of them. We're going to rely on something that has already been built. So as with everything, you should firstly check that things are properly built, but it's usually a good idea to use battle-tested and audited libraries that already exist, because A, you don't have to write them yourself. It saves you some time and development energy, and B, you can also rely on their audit reports and be able to further your security assumptions on this point. So you don't have to go through it again, and you don't have to do a lot of work yourself. Okay, so and the easiest way to implement an ERC20 token is pretty much to follow the Open Zeppelin guide. So what do you need to do? We already have this Pragma Solidity. This is just a bit different version. You need to import the Open Zeppelin ERC20 token and create a contract that uses it. Okay, so I'm just going to copy this import so I don't have to retype it. In your case, you can retype it if needed. And I'm going to go back to Ethereum. I'm going to close this contract, and I'm going to create another contract on top of it. I'm going to say, okay, so contract my token. First, I'm going to paste the import, contract my token. And as with the Open Zeppelin, I'll have to set some things here. So in the constructor, when the contract is initialized, I'm going to also call the constructor of the ERC20 token with the name of the token and the symbol, and I'm going to pre-mint something to the sender. I'm going to just create my tokens immediately for me. So let's do this. So contract my token, constructor, ERC20, and let's say it's going to be this, and in constructor is ERC20. That's going to work. So I extend the contract. I call the constructor. I'm just going to call mint, and I'm going to mint to message.sender. This is the initiator of the transaction, and I'm going to mint 123 Ether. So everything in blockchain, specifically with tokens, is done with 18 decimals of precision, and Ether is just a shortcut to multiply these by 10 to the power of 18. So we have a whole token. Okay, so that's the token. Compile the contract. The next thing I need to do is I need to deploy it. And the procedure is the same as before. So I click deploy here. I just need to select a different contract. So this time I select my token from counter.sol and I deploy it. I need to, again, pay for gas, wait for a while for it to get deployed, and that's it. Okay, my token is deployed. Yay! And as before, I can interact with it immediately from here, or I can interact with it. I can copy the address and try to see if it is available on Block Explorer. Well, it is available on Block Explorer, and because I've inherited from the Open Zeppelin ERC20 token, the the block explorer immediately picks up and says, okay, here's a token name, my awesome token. And it also says there has been one transaction, there has been one internal transaction. And if I click on this token here, my awesome token, I can see that there's exactly one holder, which is me, which happened just about a minute ago, and it holds 1, 2, 3 tokens, which is the same amount as here. So this gets immediately picked up by the Explorer because of the events that are already handled up by the OpenZeppelin implementation. Okay, so that's the token. That's the simplest thing you can do to create a token. Pretty much you need to take an existing implementation, get a name, get a symbol, and push it on. Okay, so that's one thing. The second thing we're going to do is we're going to make this token a bit more interesting by using the FTSO system to price it. So instead of having a token here that is just pre-minted to myself, I'm going to create a specific method that says buy. So I create a function buy that is payable and public, that allows you to put some things in, that allows you to put some coins inside, and then allows you to take some, and then we'll do something with it. So what am I going to do? Well, I'm going to say the following. Okay, so however much you put in, I'm going to mint that much tokens to you. So I'm going to do the following and say, okay, I'm going to mint to message.sender, to the initiator of the transaction, and I'm going to mint message.value. So the amount you've set in. So if you put in 2 FLR, I'm going to mint you 2 tokens. If you put in 2.5 FLR, I'm going to mint you 2.5 tokens. And what do I need to do now? Well, again, I have to recompile this, and I'm going to deploy it. My token, I'm going to deploy it here. And let's check this token. So if you go here in the remix, you can see the transaction, you can see all the necessary information, and you can see, okay, so it's usually very nice to check what specifically has happened. So you can check the full transaction and so on, and things that have been emitted. But the important thing is, let's now see how our token behaves. So if I copy this one and check it, and check the token, I can see again I have 1, 2, 3 tokens, but now I'm going to call a function buy on it, and I'm going to say, well, I'm going to send 10 additional ether to it, and I'm going to call function buy. If you see something else happens and it says, okay, you're sending a transaction that's a bit bigger, and now it costs you 10 cost on flare because I'm sending this additional cost on flare in, because this is getting sent to the contract directly. I confirm this, wait for a while for transaction to finish. And if I go back to the Explorer, I can immediately see that I have one more token transfer that has come in. If I refresh this, I can see that, oh, the same guy has now minted another 10 tokens. And if I go to holders, I can see that now I'm holding 133 tokens. Okay, cool. That's the simplest thing, the token. But we're still missing one thing, and that's how exactly do I make this contract verified? Well, I can use the same thing, but now I would have to import all this data from ERC20. So the easiest thing to do is to do the following. So you go here in the remix to plugin manager, and you search for validate. So I already have this installed. So I already have the contract verification modules installed. Otherwise, you just click on activate. You go to here to contract verification. You go to settings, and you copy the address of the, you go to settings, you go to block scout, you copy the address of cost on Explorer, you copy it here so that you have custom-explorer.flare.network, and then you go to verify, and you select contract address. You put the contract address here, and you also select which contract you want to verify. In our case, my token. I'm just going to select Block Scout. I click on verify. I wait for a while, and then if I refresh this, I can see that the contract is now verified as an exact match, and I can interact with it. Okay, so that's the contract, that's the token, and the Block Scout already tells me everything I need to do. This is the contract, this is the things I've used, those are the things I've imported, and I can also interact with it, write with it, add it, and so on. Importantly, as this is a token, here's a nice button to add this token to MetaMask, so you can send it as if it were a USDT, USDC, whatever. Okay, so we've done a few things. We've created our first contract, our first token, and we're able to mint our first token. And now the final thing has to come, which is we're going to use the FTSO system to set the following. So we're going to be issuing you one token for each dollar you send in. But the problem is, on Flare, we don't have dollars. Well, we do have stable coins, but we're going to say, no, you have to pay with Flare, but we're going to issue you $1. We're going to issue you as many tokens as dollars you've put in. And this is usually difficult to do on blockchains, but it's not that difficult to do on Flare, because you can always use FTSO system to get the amount of how much each dollar is worth. And how do you do this? Well, we're just going to query the FTSO system. If you want to know more about the FTSO system, there's a very nice developer hub page you can use, but I'm just going to copy some code from where I've prepared it and explain it later, and explain it while I'm copying it, and we'll go through it in the next few sessions when we're going to explain in depth how exactly that works. Okay, so what I'm going to do is I'm going to just copy a few imports of this Flares token. So I'm going to import Flares libraries, which allow you to much more easily access the FTSO system. So you don't need to know where things are happening. You don't need to know which specific ABIs to use, because you easily import them from libraries and they get checked directly on-chain. And the thing I'm going to do is I'm going to go to the FTSO system and say the following. So in this function buy, instead of buying things directly, I'm going to say so. So I'm going to say, okay, contract registry, go to Flare contracts. Please check, please get me the test FTSO v2 test, because we want to use it on a test network and we want to use it in production, and get me the feed by ID in way. So get me feed value by ID in way. And which ID we want to get? Well, if we're going to be putting Flare in, we want to get Flare. So the easiest way to get Flare feed ID is just to go custom systems explorer, check the Flare feed, copy it, put it here, and we got it. So here we get feed value and timestamp. And now the only thing we need to do is, when minting, we have to say, okay, so we're going to mint to message sender, we're going to mint message value, and we're going to multiply this by feed value. So if we know that each Flare is worth 2 cents or 2.3 cents, that means that we multiplied by this in way, so multiplied by 10 to the power of 18, and the more the Flare is worth, the more tokens we get. And then we also divide this by 10 to the power of 18, just so that we remove the way at the end. Trust me, the formula checks out. So the greater the value, the more coins I get, and the greater the feed value, so the greater the Flare dollar value, more coins I get. Okay, and that's it. So this time we've updated our buy function to make it a bit more powerful. So instead of just minting as tokens, it firstly goes to the FTSO system on Flare, checks the current price, gets the feed value, gets the message value, so the amount I'm sending in, calculates how much dollars this is, and then immediately execute this and mints this to me. Okay, so the only thing I'm left with is to just run this and compile it and see how much I get. Okay, so What I'm going to do, I'm going to clear all this. I'm going to deploy my new token, my awesome token with FLR. I just have to recompile it. I'm going to deploy it. Okay, and this time I'm going to be sending, let's say, 17 FLR in, and I'm going to be buying some additional tokens. Okay, and the only thing that's left is for me to check what's happening with my token. And you can see, well, initially I got 1.123 tokens, so this is the pre-minting I did. And then when I sent 70 FLR in, I got another 0.34 token. Okay, and that's mostly it. So how do I verify this contract? Well, simple. I just go to the contract verification, go to verify, select the address, and say that I'm verifying my token. Select Block Scout, click verify, and the only thing I need to do is to go here, and the token is all here. You can see the code, you can see everything. Okay, that's it. I'm going to be giving you, this code is going to be available once I finish this on the final Notion page, so that you can always look at it, you can check it, and you can use it if you want to build something amazing yourself. Okay, let's go back. It's the counter, that's the ERC20 token, the FTSO connectivity, and yeah, so if you want to learn more, here are some additional resources, the Dev Hub, the Twitter. You can ask us anything on Discord, and now it's time for Q&A. And while we're still at Q&A, here's the join the fun. So you can scan this QR code and continue your interaction with FLR networks and with FTSO and with tokens, and play around, do something. And we're going to keep this open until Friday evening. So, and if you successfully submit whatever is needed to be submitted in the Notion page, so there are full instructions, you are eligible to win a full FLR merch set. So I hope you enjoyed this, and let's see what's here from Q&A. Okay, so the questions. First question is, what are the pre-requirements for deploying smart contracts on FLR? Wallets, tools, access to custom, and so on. So the pre-requirements are the following. So you need to be able to sign a transaction on the network, and the address you're signing this transaction with should have some funds. So the first pre-requirement is you need to have an address generated for the network. FLR is an EVM network, so if you have address generated for Ethereum, you can reuse this address on FLR. It's just going to be signing a bit different message because the chain ID is included in it. But to do this, you usually need a wallet. This is the thing that usually signs the transaction. And the easiest way to interact with this is to use some tools. So I've showed you how you can do this through Remix, which allows you to directly query the MetaMask that signs a transaction and pushes it on chain. But the only things you need to do are you need to get some funds to fund this transaction, and you need to sign a transaction. And the easiest thing to sign a transaction is to use wallet. And to publish a transaction, you need access to an RPC node that connects to the network, and those can be found pretty much anywhere. So pretty much put into your favorite search engine name of the network and RPC, and you'll get them. So you can get them for FLR, Songbird, and both for testnets for both. Okay, the second question is, what makes FLR smart contract deployment unique compared to Ethereum or other EVM compatible networks? So the deployment is the same. So pretty much any contract that is currently deployed on Ethereum, so can be viewed on Etherscan or on other EVM compatible networks, can always be deployed on FLR. The things that makes FLR unique are the things that run directly on network. So it's not the programs themselves that are unique or writing the programs that is unique. It's what the programs can access. That's the only unique thing. So anything that can be deployed on other EVM networks can always be deployed on FLR. It's just that on FLR you have these additional rich things you can use when the program is running. What tools or frameworks do you recommend for debugging and testing smart contracts before deployment on FLR? So as said, those are only recommendations. So for debugging and testing and developing, I usually use either Hardhat, but we're slowly moving to Foundry, which I really like because it allows you to create your whole development procedure, create all the testing stuff and all this. So I would recommend either Hardhat or Foundry from my side. There are other tools that you can use, but though I find those two to be the easiest one to start with. And then for tests, they all have the integrated testing suite and the integrated unit test, and you can also run some a bit more strong end-to-end tests and fuzzing and so on. So to start, I would recommend those, but there is a lot of additional tools on top of this, how you debug and test and do all this if you want to have a bigger project, if you want to do this a bit more thoroughly. But to start with, I would say Foundry and Hardhat. The next question is, are there any specific optimizations or best practices for deploying cost-efficient contracts on Flare? The same optimization and best practices as on other EVM chains applies. So specifically on EVM chains, the most expensive thing you can do is to touch the memory. So for example, multiplying two numbers with each other costs you, I think, 5 gas. Adding them costs you 3 gas, while saving something on chain forever costs you 20,000 gas. So we're talking about orders of magnitude of differences. And this is usually the first thing you need to care about, which is pretty much the same across all EVM networks. So be careful what you put on chain, be careful about your memory. How can I integrate Flare State Connector with my smart contracts to pull real world data? Well, the easiest way to see this is to go to the Dev Hub when we're currently upgrading the docs for State Connector to work with FDC. So the developer experience is very similar, but it usually processes in 2 steps. So the first thing you do with State Connector is you request the Flare's network to attest that they've seen something somewhere else. So this is the first step, and this can be done mostly off-chain, and just the request has to be submitted on-chain. And then once the network confirms this, your DApp needs to source the full data point together with the proof showing that this data point was indeed confirmed by the FDC in some previous round when somebody requested it. And then you push this to your DApp. The DApp checks that this data point has indeed been included in your FDC because the DApp might not trust you. And then the DApp can interact with this. So it's a 2-step process. So you first have to request a confirmation, and then you provide the application. With the information on how to with the information on why this specific thing was confirmed. The next question is, what support does Flare provide for bridging smart contracts from other chains to its network? So usually when we talk about bridging, we're not bridging smart contracts. We're bridging either information about smart contracts or we're bridging tokens. So what kind of support do we provide here? So there are multiple ways of bridging things from other networks to Flare. So one of them is, of course, the FDC. So FDC, or Flare State Connector, or Flare Data Connector, allows you to bridge information from Bitcoin, Dogecoin, EVM networks, and XRP Ledger. What this means is that on Flare, you can know what's happening somewhere else. So this is one way to do it. And the second way is you can use one of the bridges available on Flare. So for example, you can use either layer 0, which is a general message passing protocol, or if you want to bridge a specific token, you can use Stargate to just bridge a specific asset across it. And yeah, I think we have time for one more question, which is, why are the transaction fees so much lower on Flare than Ethereum? Well, the transaction fees are set as a sort of optimizations. So in case of Flare, we're trying to make network as efficient as possible, and we made sure that the network fees stay low. But in case when there's a congestion, in case when there's a lot of people that want to make a transaction, like you can see when there's, for example, Flare drop claiming, the network fees might rise. So this is the network fees are usually low because we want to keep them low to make the developer effort and user experience more nice and easier. but during peak times when a lot of people are using the network, things can pop up and the transaction fees can be a bit higher. Okay, so and there was another question about F assets, which unfortunately I cannot answer on on a thing like this. So, but I'm pretty sure there's going to be some information about this very soon. Okay, so that's all from me. Thank you for joining this. Scan the QR code. I'm going to put the code samples that we had today on it, and have fun deploying the token. And I would be really glad to see what you're building, what you're working on, and I hope we see each other on the next session of this, when we're going to learn even more things about Flare and we're going to do a deep dive in the oracles.